Welcome to part 4 of our solar troubleshooting series. In this part, we're going to be talking about repairs. If you have not watched parts 1 to 3 of the prior presentations, please go back to do so. This part will not make sense without those other 3. In part 1, we talked about an overview of solar, the types of systems, types of inverters, and types of components. Part 2, we talked about doing a visual inspection. In part 3, we talked about doing an electrical inspection and troubleshooting. So part 4 is all about solutions and choices. Based on what you discovered in parts 1 to 3, you'll have to make some decisions and recommendations. In this presentation, we're going to look at some of the options and look at the positive and negative sides of each option. It is extremely rare, again, let me repeat that, is it extremely rare that you need to replace an entire solar system. So, the types of failures or damages that we come across is failed or damaged wiring. This could be sun, animal, or age-related damages. We could have failed inverters. We could have failed panels. And we can have no actual damage, just age, degradation, and owner expectations. Systems eventually will go past their lifespan. Everything will fail eventually. The first item, failed wiring, the repair is easiest on this option. Replace the failed wiring. If it's age or weather related, look at similar wiring in other sections of the system. Other sections may be about to fail as well. For roof-mounted arrays, it may be a little more difficult to get to some of the wiring, and you may have to lift panels from the mounts. This is not a one-person job. When quoting this work, remember safety and roof access. Connectors are not all that expensive. They are one of the major points of failure in any solar system. Okay, the waterproof cable connectors, okay, they handle 10 AWG wire, but they're not that expensive. Just remember you have the tools to go along with them. Solar panel wiring is not all that expensive either. Okay, red and black 50 feet, 10 gauge, tin copper wire. It's designed for outdoors. It can handle being in the hotter weather. You also have some additional wiring that you can get that's actually, it's a double pair solar cable wiring. So look around and see what's available. Failed inverters. They don't have serviceable parts in them. When they're dead, they're dead. The repair option on an inverter is to replace the inverter. For micro-inverters on roof-mounted arrays, this a lot of times means lifting panels to get to the micro-inverter, and then it's a series of plugs or connectors to unplug and plug in the new micro-inverter. Before changing a micro-inverter, double-check those connections. For ground-mounted arrays, this is easy because you can walk under the panels to get to the microinverter. For the most part, inverters are universal. They do not care what panels are attached to it. Match the inverter input and output characteristics, and if you cannot find the exact module, go a little bit larger. Never go smaller or you're going to cut into the production of the system. This is just a search on the Sunny Boy SMA inverters, okay? They still make them. They're available. They're available in all sizes. I would stay away from the used one. That's why one of them has a red square and X's away from it. Don't buy this stuff off eBay. It isn't worth the savings. Microinverters are available just about any place. Hey, if Amazon carries them, you can get them from anywhere. Just again, match the wattage and the voltages. Okay. Failed optimizers, they're cheap. Okay. Just replace the optimizer. Again, you might have to raise the panels on roof-mounted arrays. They're $88 a piece, okay, through the Alt-E store. You can also get them on Amazon and other locations. Failed or damaged panels is the category of damage that can cause you the most headaches. You cannot repair a solar panel. Damaged panels have to be replaced. Have a conversation about the electrical testing results on the damaged panels. Microfractures or micro cracks many times do not affect operation. Major cracking will. The physical size of a panel matters. The color of the frame matters. This is all due to line of sight. Here's an example. There were a couple failed and damaged panels on this array. Okay, the exact panel replacements are no longer available. If you look over here on the right side of it, you'll see that there's been two smaller sized panels added. Believe it or not, those two smaller sized panels actually produce more power, each one of them, than one of the larger panels does. It has to do with how long ago those other panels were made. Okay, again, those two panels over on the right, but you'll notice they don't match the rest of the panels. Now, this is an area where it's basically a wide open farmland. It's not in a neighborhood, and it's not the first thing people see when they pull up to the house. So the owner here decided to go ahead and just accept the different look of the panels in order to get the output of the system that they wanted. Over the years, manufacturers have continued to change the dimension of the panel. That's the biggest issue. The newer panels also have different electrical characteristics. Output wattage is higher. Voltages are sometimes different. For all of these reasons, it's sometimes very difficult to replace a single panel in an array. Line of sight rules apply in some parts of the country. An array in a neighborhood may have different requirements from what is in the farmland in the middle of nowhere. By line of sight, if you stand at the curb and look at the building, okay, this is specifically for roof-mounted arrays. If you look at the house, you should not see the difference between the new panels and the existing panels. First, find the exact dimension of the panels. You can do this by finding the specification sheet on the internet. Next, use those dimensions and the panel's output wattage to locate possible replacements. If you're extremely lucky, you'll find the exact replacement. If not, read on. Okay, this is an example of a data plate. It's a Sanity Solar GES6M255. It's 255 watts at peak, 30 volts at peak, amperage is 8.5 amps, circuit amperage 15 amps max, system max voltage 600 volts. Okay, now we go online, find using that spec sheet, using the model number, and I can find the exact dimensions of the panel. It's 64.6 inches long, has a width of 39.1 inches, has a depth of 1.6 inches. The depth is basically, if you're looking at the panel from the end, it is what the height of the outside portion is. That's the portion that clamps on. A quick Google search shows that all 255 watt solar panels on the market are reconditioned or used. Sanity Solar is no longer in the business anymore. So we have to find other options. 255 watt solar panels are, anything under 300 watts you're not going to find much of anymore. So we can look at some other panels, okay? This is the MC4 connectors, the STC 550 watt panel from Marinology works for voltages, amperages, everything else. It will fit our system. But the dimensions are wrong. 89.7, 44.6, 1.4. It's not going to fit the other panels. It's going to hang out below it. So again, this is where decisions need to be made. Physical size is the problem here. The difference in the output wattage and voltage, do some math to see if there's a downside of putting the higher wattage panels in the string. For micro-inverter systems, there's no harm as panels operate independently. For string systems, the greater wattage of the new panel will normally make up for changes that occur with the rest of the string. If you're dealing with an older array, the increased wattage of one or two panels may make up for the age-related degradation of other panels. You may also want to consider putting optimizers in. Unless the panels were installed over 20 years ago, the connectors on the panels are universal and easy to change if they're not to modern connectors. All panels have a positive and a negative connector. Just you have to know which is which. If you cannot find an exact match or a close enough model of panel, then you need to look at the arrays and see if there's a way to replace a portion of them rather than the entire system. To maintain visual appearance of the arrays, it is sometimes advantageous to move panels around so the new panels make up an array and all the other panels are made up of the older panels. You'll end up with a few spares, but that never hurt to leave for the customer. Here's an example of what I'm talking about. Okay, in this example, I could put a new panel in over here on the left side. Okay, there's a new panel needed. Okay, on the house, on the roof here, if I put a new panel in where the red mark is, I can move, or if these are the damaged ones where I'm circling now, I move the two panels in my green down to there. That maintains line of sight. These are up high enough where no one sees them. I could put the new panels in here and they don't have to be an exact match look-wise. The only people that are going to see them is people flying over the house. So you can look and see where it makes visual sense before you replace entire system. If this doesn't work, I would still move that panel down there, and then I would just replace this array with new panels to maintain visual appeal. In this example, this is one array that's pretty solid. If I have dead panels where the red square is, I'm going to end up replacing the entire array. Okay, because again, the visual line of sight doesn't work well here. And I'm not going to find panels with the exact dimensions and look. The frames are going to be different. If you're replacing a failed panel and the microinverter is in good shape, you don't need to replace the microinverter, especially if it's relatively new. If you're replacing a failed panel in a string system, the inverter does not need to be replaced. The connections are universal and have not changed. Just double check and make sure positive and negative are connected to the correct points. For older inverters, you may need to make some crimp connections to match them to the new panels. No damage, age, or owner expectations. This is the most difficult situation for any service technician to deal with. A system that is 10 to 15 years old is not going to be performing in the same manner the system was when it was first installed. For age-related issues, do the math with the owner and show them the facts. Sooner or later, they're going to have to make a decision. If the system has multiple arrays, perhaps recommend that they start thinking about replacing panels array by array. That way they might be able to fit it in their budget. It's also important to remind them that newer panels have a higher wattage. So if we replace an array of 10 250 watt panels with 10 350 watt panels, that's an extra kilowatt out of there. So I mean, that may be the way to do it. It fits it into their budget. It's not an entire system at one point. And a lot of times they won't have to take out a loan, which people are right now hesitant about. Another one we hear a lot is the utility bill has increased, so their solar must not be working properly. This is one you hope the utility company has integrated meters and they capture both the power used as well as the power generated. Or the owner has a power management system tracking that part of the system. Do a quick web search on the inverter make and model. You'll most often find a way to connect a browser to the inverter and look up the history. Look at the numbers with the owner. If the power generated remains somewhat the same and usage climbs, the problem is not with the system. Don't ever look at or discuss the price, cost, and billed amount. That changes. Utility rates change. They change fuel rates. They change delivery rates. All you have control over is the actual kilowatt hours that the system generates year to year. That you can explain. The rest of it you can't. So in this shorter presentation, I wanted to give you some options for system repair before you get into system replacements. There's a lot of waste, both monetary and environmental and time, to replace a solar system for something that could be repaired. try to find a repair option first. It's better for the customer, which in turn is better for you. Replacing an entire system is a short-term gain, but that customer is eventually going to be upset over that being done if there was another option. What's presented here is not all the scenarios. I'm going to get 1,000 emails saying, well, in this case. No, there's always other additional consideration. Take this as just one set of things to look at. And again, my standard disclaimer, the opinions expressed in this presentation are my own and are not those of my employer. If I say something you disagree with, blame me, not my employer. And to repeat, this presentation is not designed for the do-it-yourself owner. There are serious safety concerns when servicing a solar system. Only do so if you're properly trained in electrical and ladder safety. I don't want to see anyone get hurt because they're trying to do something in my videos that they're not qualified to do. Please be careful.